Hello everyone, welcome to my channel Skillset Academy. I am Arif Anis from Skillset Academy, and today we are going to start our first SDWAN course, Cisco Mastery of SDWAN, right? So today this is the first class, day one of our Cisco Mastery of SDWAN, and today we are going to discuss about the history of WAN and the WAN limitation, right? So today we make a stage to enter our smart and trending technology, which is SD-WAN, right? So let's get started and we dive into our Microsoft Windows board. Okay, so here that is the day 0 and background and evolution of WAN, right? So what's the purpose of WAN, right? We have to understand the purpose of WAN, right? So the purpose of WAN, we know, to extend our network, right? Or to connect remote branch, right? To connect remote branch is the purpose of WAN, right? Because we are okay with Ethernet technologies and we are using the LAN, right, to connect and share files within the network. But when we come to start the or when we realize the importance of the WAN and we start the WAN technology, and the first WAN technology was introduced on 1960 by the US Air Force. What was the reason? The reason to connect the radar system across North America, right? So the first use of WAN in 1960 by US Air Force. Okay. So the second 1970s, we know the ARPANET, right? The revolution of WAN technologies, right? And it was revolutionary, right? And the WAN, first WAN connections was connected the research institute, right? And enable the sharing of information over long distance. What was the technology that time? The packet switching, right? So the ARPANET was the technology of packet switching, and to utilize this ARPANET in 1970s, they use or they share the information using packet switching technology, right? And in 1980s, the commercial use was started, right? And we know the lease line and frame relay, right? So we will discuss in depth or further in this video, right? What the use case was these lines and frame relay when we will discuss about the limitation of traditional WAN, right? So again, 1990s, the internet was boomed and the internet protocol was become the standard, right? And the IP protocol was robust and scaled the WAN solution in 1990s, right? And another improvement of WAN technology was introduced when we introduced the MPLS, right? Multi-protocol level switching. In right? In 2000, multi-level protocol was introduced and it's become popular, right? So in 2000, multi-level protocol become popular, not introduced, right? And MPLS improved the performance and management of WAN. Okay, and what the technology was introduced with MPLS, the label switching. Okay, it is add label to route packet from one WAN to another WAN, right? Or one side to another side. Again, 2010, the cloud and mobility, right? It took place. So the cloud and mobility that 2010 shows a shift towards cloud computing and mobile connectivity, right? So the traditional WAN technology was struggled, right, to keep up the increased demand of bandwidth, right? So that time applications need flexibility, scalability solutions, right? So that was the time the actual struggling of traditional WAN was started, right? And now the modern era SD-WAN represents the latest evolutions in WAN technology, right? This is the WAN technology evolutions, and this is the latest WAN technology, and it addresses the many of limitations of traditional WAN, right? By using software to manage and optimize network resource dynamically, right? So it addresses lot of limitations, but we are going to discuss some of limitations, right, of traditional WAN, and then in next video we will discuss the solutions of traditional WAN limitations, right? So today's video we are going to discuss the limitation of WAN, and another video we will again discuss the limitation of benefit of WAN or the solution of these traditional WAN limitations. Okay, so I have drawn here a traditional enterprise network, right? How it looks like. Okay, and we will discuss the all of the points using this diagram. Okay, all points are the limitations of modern technologies, right? So the need of scalabilities or to need of multi-cloud connectivities, right? So the traditional WAN is struggling now, right? So let's discuss the first point, high cost, right? So high cost means, suppose, just first I brief the diagram here, right? So in traditional networking, what we are doing now, we have a data center here, right? This is our data center, okay? And in data center, we have applications, okay? And we have firewalls, okay? So what other branches are doing, they are using MPLS circuit, right? Here is the MPLS circuit, okay? And their users are using MPLS, right, to reach this data center and to use these applications as well, right? Now, let's discuss why we are not able to connect our remote branch directly to internet, because the MPLS link also provided by ISPs, right? And they can also provide internet as well. But why we are not using internet locally, right? Why we are using backhauling? So the reason is again the cost, right? So if we want to terminate our internet locally or break out internet locally, we have to have the firewall mechanism on remote branch, right? And we all know it associate with cost. So suppose we have 1000 branches, right? So if we break out internet locally, we have to introduce thousands of firewalls in our branches, right? And if we just associate the redundancy, so this number will multiply by 2, right? Active and standby. So we have to use 2000 firewall if we have 1000 branches, right? So it's huge cost associated with the local breakout of internet, right, in traditional network. So what usually we do, or the enterprise will do, they are using the MPLS link to connect their applications which is resides in data center. And also if users want to connect internet, they are using same MPLS link to come to this core firewall, right? And from this firewall, they come out by internet and they use internet from same links and they come back to this branch, right? To the users of branches. So this MPLS link is also costly, right? This associate also a cost. And again, we have multiple sites like 1000 sites, right? So to manage all those sites, we need more resources, human resource, right? Engineers, network engineers to manage all sorts of routers or switch or firewalls, right? Routing, switching, firewalling. So we need more. Again, link utilization. So here also we are wasting our money to not utilize proper link. Okay. So here I drawn the ISP link, right, to discuss this link utilization and link failure, right, or and multiple transport. So we have two link, right? Usually we have multiple links, right? We have multiple ISPs, two or three or four, five ISPs, and both ISPs provided us the uh, redundant link as well, right? Primary and secondary. But for the sake of simplicity, I drawn two links here, right? One primary and one secondary, right? So we are using these two links in the active backup manner, right? We are using primary link in case if primary link goes down, then on then only we are using backup link, right? So we are not utilizing our link properly. Okay, so this types of problem will be solved by using SD-WAN, right? So in next video we will discuss about the benefit of SD-WAN, how SD-WAN helping us to solve these limitations, right? So link failure, again, this is the another challenge to handle link failure mechanism in traditional WAN, right? Suppose you are using the primary link and suddenly you observing 30% packet loss in primary link, right? But still you have to use this primary link because you don't have such types of mechanism to shift link automatically, right? Unless this link goes down, right? because we know without this link going down, this router will not remove the route associated with this link. Okay, so the next hop will not be removed until unless this link goes down, right? So after going down this link, this router will remove the route associated with this link, right? Then and only this traffic will shift this secondary link, right? Or backup link. So this is one kind of challenges which traditional WAN are struggling to solve this issue, right? But very simply, SD-WAN will solve this problem, right? So we will discuss further again. And the multiple transport is also a problem that local or traditional WAN routers, they are not capable to utilize multiple transport means multiple types of links means the internet link and the private WAN link, MPLS link, or simultaneously it will not capable to use 4G, right, or 5G or Wi-Fi WAN, okay, or 5G, right? So it is not capable to utilize multiple transport. But in terms of SD-WAN, it will support multiple transport, whether it is WAN or it is internet link, bridge internet to business internet, or it's a MPLS, private MPLS, right? Or 3G, 4G, 5G, WAN, Wi-Fi, WAN, all are supported by SD-WAN. Okay. And again, the load balancing. So to load balance in traditional WAN, it's another a complex and challenging task, right? We have to do lot of we have to use lot of protocols to load balance our traffic here, right? So we have to use SLA, right? We have to use tracking, right? So we have to use routing and many things, right? There are a lot of challenges to handle the load balancing, right? So again, these problems will be solved by SD-WAN, and the box to box configurations is a more challenging and it's a repetitive task, right? And we have to use the multiple resources to handle. If suppose if you have again 1000 branches, right? And 1000 branches, you have 1000 routers, right? Again, you have switch 1000 switch. In case if you are using redundancy, then it will increase into multiply with 2 and this number will goes 2000, right? So huge number of routers and switches there, right? So this is the core switch and core routers. Again, we have a multiple access switches, right? So if you have a 1000 branches, so you minimum you have to manage 5000 devices, whether it's a router or switch or access switch or core switch, right? So you have to have you have to log in. Suppose you are going to change SNMP from 2 to 3, right? You are going to implement SNMP 3. Okay, so to configure SNMP 3, you have to log in these 5000 routers or devices, and manually you have to go to push the configure the SNMP, right? And again, you just box to box configurations will be needed to configure SNMP, and you can't imagine how these tasks are time consuming, right? And resource consuming also, right? So box to box configurations also a challenge, right? Which is not smartly handled by this traditional WAN network, right? And again, the software image management, right? It's again a huge complex task, right? Sometimes we need whole days, right, to upgrade our iOS image. And obviously, you need to downtime to upgrade your software, right? And again, you have to log in the box to box manner, right? And you have to copy your switches. Sometimes we copy software image to your devices, so whether it's a router or switch or firewalls, right? And sometimes we run the copy using TFT, and some uh, after uploading 80%, 85% or 90%, the message will come up. There is a shortage of space. Again, we have to remove some spaces, right? To clean some spaces, some files. Then again, we have to upload the iOS image. Then we have to run the iOS upgradation, right? But in SD-WAN, it will be just a matter of time, right? It's just a you can schedule as well. We will discuss in detail in next video. Again, the backhauling, right? Backhauling is also a challenging, and it also associated with cost in it, right? So it also reducing the performance of applications, because we know the era of cloud, right, where mobility is and home users are a necessary. It's a becomes a normal norms, right? So still in this cloud era, if we are using backhauling, right? Suppose your branch here, right, and you are using internet or applications via your data center. So what we are doing, we are going again to this data center, and you are using applications. And again, there's applications like earlier we are using email locally, right? We we have to have the email server on our in data center, right? And our branch users are they were using the local email via MPLS. There was no problem, right? There are just that situations was adjustable, right? But to use internet, and where you are using same MPLS link to use your data center applications, again you are using same link to go to this internet, whether you have internet in your ISPs, right? But you are not able to use this internet link, okay? So you are covering the whole way, right, to this data center, and then go to this internet and again come back here, right? So it's a backhauling. But now your email are not located in data center, right? The email is local email is transferred to the cloud, and now people are using Office 365 for email, and lot of other cloud applications, they are moving from on-prem to cloud, right? So now, if you are using your cloud applications via your head branch, then you will suffer lots, right? Because all the companies, they are hosting their applications in clouds, not in data center, right? So backhauling will be challenge to optimize your application's performance, right? So backhauling is also associated with cost. If uh, you increase this MPLS bandwidth, you have to pay more, right? So we have a mechanism called direct internet access in SD-WAN. We will discuss and to solve this problem, right? The DIA will solve this problem. Again, the backup and link path health monitoring, right? we have a separated team to monitor this link, right? We have a mechanism, we have a Negus server to monitor our link, and you have a separate team, monitoring team, those who are monitoring all your link health, right? But believe me, in SD-WAN, just a huge solutions, right? It's a monitoring solutions is a huge. You will not only monitor this link, you can monitor your remote router's health also. You can monitor your router's CPU, your remote branch router CPU, RAM, right? Memory, okay? When link optimizations, which applications are using, right? All can be done by this SD-WAN solutions, and no need to log into all of these routers, right? In a single monitor, you will have all those facilities, right? So auto backup is also there, right? No need to backup, right? You will have the configurations on your router, on your controllers. From there, you can add the all times. It can monitor your all links, right? They will, they can monitor all the links in real time, right? So if your link or your device, you can set the notifications as well. If your device resource utilizations will go up to 80, you will get a notifications message via email. So that type of solutions there. But in traditional WAN, we have a lot of challenges to get this types of benefits, right? Again, the IPsec configuration is a nightmare, right? Here we have a partner devices, right? And we have a VPN devices or firewalls, right? And dedicated team are configuring IPsec configurations with our partner, with our branches, right? With our branches. So the dedicated team will be needed to configure, and you know the IPsec configurations and troubleshootings are complex, not an easy task, right? So IPsec configurations within your organizations, within your branch, it will be automatic. There will be no manual configurations or manual interventions to configure IPsec automatically. And again, the cost we will discuss the cost and security using DTLS tunnel and IPsec. So the IPsec also it will use traditionally we are using ESP, right, in IPsec in phase 2 to encrypt or to data security, we are only using ESP protocol. But SD-WAN increase this security ESP, and it mimic the authentications header protocol to increase security of SD-WAN IPsec, right? So it will provide you the more security with compared to traditional WAN. And the vulnerability assessment, there is no need to assess your vulnerable assessment or pen testing, right? So the vulnerability assessment will be done automatically. So in your organizations, in your uh, fabric, in your switches, routers, in uh, any vulnerability will be found, it automatically detect this vulnerability, and it will provide you the remediations as well. How you can solve this vulnerability, you will notify via this SD-WAN controller, right? But in in traditional WAN, we are facing the problems to mitigate this vulnerability assessment, and we have a dedicated team to mitigate this vulnerability, right? Again, the RMA device change is a Again, a hassle-full task, right? We have to send our field engineer, and sometimes it will take whole days, right? Because sometimes your field engineer will go and they will forget their passwords. They have to reset their password. They try to reset, but it will take time, right? So whole days will go to the RMA device, right? To log in, to configure, right? So to change faulty device. But in SD-WAN, it's a time of need you the 1 minute. No need to work any manual task, right? You can just remove the existing device, remove the existing device from the rack and deploy the new device and connect the link as it is. And the field engineers work done, right? They don't no need to do anything else. When this router come up, automatically will be connected to this SD-WAN fabric, and from this fabric they will connect to this controller, and the controller will have the configurations, and controller will push this configuration to this newly device, and this device will join to this fabric. App ever routing, right? If suppose you are using an applications which are resource incentive, which are bandwidth sensitive, right? But again, your device is your link is getting packet loss, but you can configure the device level your backup, right? So application ever routing, this router this router is not capable to identify application, right? This router will not be able to identify which applications is going on, and according to these applications, it will not be able to determine the task what it has to be it can do, right? It has to be done. There is no mechanism in traditional WAN. Again, we have a separate mechanism for application aware routing. Application optimization is also can be done by SD-WAN, and the multi-cloud connectivity is also a multi-cloud connectivity is not feasible with this traditional WAN network, right? So the multi-cloud connectivity is challenging for this traditional WAN, because again you will travel all the your ISPs, then will go to this data center, then you have to go to the internet, and from internet you have to log into this cloud. And if you have multiple cloud, then you will face a multiple problems, right? So this is the limitation of WAN. What I want to discuss about the limitation of WAN, right, in this video. And I am requesting all of you, if you are getting this helpful, right? So please like, and what we will do in next video, we will going to cover the benefit of SD-WAN, how this SD-WAN identify this problem and mitigate all types of problems, right? So thank you for watching. If you found this video helpful, please like, subscribe, and hit the notification bell so you don't miss our next lecture, right? So, and also feel free to leave any questions or comments below, right? And let's meet in next video. Okay, thank you very much.